time to listen to me whine about nothing and everything all at once. I am one of those melodramatic fools, neurotic to the bone, no doubt about it. Sometimes I give myself the creeps. Sometimes my mind plays tricks on me. It all keeps adding up. I think I'm just paranoid. Okay, so we are going to go ahead and get started. We are doing Chapter 5, Lesson 4 today, Terminating and Repeating Decimals. Students will be able to use the terms terminating and repeating decimals correctly. That's what we're getting out of this, okay? Also, make sure you are writing down everything that is typed or written on these videos, and pause this video at any time that you need to take the time to write something down. Okay, remember, to turn a fraction into a decimal, we need to divide the top number, which is our numerator, by the bottom number, which is our denominator. So our top number goes in the house, and that's how we divide. Terminating decimals. Terminating means our decimal ends. And a repeating decimal means it repeats forever. Okay, it repeats forever. Okay, so repeating repeats forever. Terminating ends. A bar notation is a line that goes over the numbers that repeat. So instead of writing that number that repeats on and on and on and on, again, it can go on forever. So you could write until your hand gets super tired, or you could use a bar notation instead. A bar notation is just a line that goes over the numbers that repeat, so that you don't have to keep writing them over and over again. Okay, make sure to write all of this down before you move on to the next slide with us. Okay, so again, all you need to do to change this fraction into a decimal is dividing the top number by the bottom number. So our top number goes in the house, which is 5, goes in the house, and we divide it by 12. 12 cannot go into 5, so we're going to put a 0 up here, and then we need to put a decimal, bring our decimal straight up, and then annex a 0. Remember, annex just means we are adding a 0 that wasn't there to begin with. So now we can ask ourselves how many times 12 can go into 50. 12 goes into 50 4 times. 4 times 12 gives me 48. Subtract. We cannot take 8 from 0, so we need to borrow. That 5 becomes a 4, and that 0 becomes a 10. 10 minus 8 gives me 2, and 4 minus 4 gives me 0. I am not done because I've got a decimal. I cannot have a remainder or a fraction as well. It's one or the other. So we need to annex another 0 and bring it down. 12 goes into 20 once. 1 times 12 is 12. Subtract. We cannot take 2 from 0, so we need to borrow again. 10 minus 2 gives me 8, and 1 minus 1 is 0. Annex a 0 again, bring it down. 12 goes into 80 6 times. 6 times 12 gives me 72. Subtract. I cannot take 2 from 0, so again I'm going to need to borrow. And 10 minus 2 gives me 8. Now, we already did this once before. The last time we annexed a 0 and brought it down, we got 80, and 12 goes into 80 6 times. So we can see a pattern starts to develop here. Okay, when we subtract 80 minus 72, again, we're going to get 8. And then we need to annex a 0 and bring it down, and we're going to get 80, and 12 goes into 86 times. So the number that's going to continue to repeat is this 6. It's just going to go on and on and on. If we kept dividing, it would never end. It would always come out to be, when we multiplied back, it would be a 72, and then when we subtracted, we would get 8 again. So this is how you write this decimal. You have to use a bar notation. Okay, so our decimal is 0.416, and the bar notation is simply a line that goes over the number that repeats. So This is a bar notation over the 6 because that shows us that the 6 is the number that repeats. The 4 and the 1 do not repeat. It's just the 6 that repeats. So this is 5/12 as a decimal. Okay, now we've got -2/9. Again, we want to put the 2 in the house and divide by our 9, which is our denominator. 9 cannot go into 2, so we're going to put a 0. And then we need to put our decimal and annex a 0. 9 goes into 20 2 times. 2 times 9 gives me 18. Subtract. I cannot take 8 from 0, so I need to borrow. 10 minus 8 gives me 2. Annex a 0 and bring it down. 9 goes into 20 2 times. 2 times 9 is 18. I cannot take 8 from 0, so again I have to borrow. 10 minus 8 gives me 2. You see that we are developing a pattern, okay? When we start getting the same number each time, that tells us that something is going to repeat. And the number that we keep getting for our answer is going to be the number that is repeating. So again, if we annexed a 0 and brought it down, 9 goes into 20 2 times. Okay, so our 2 is the number that repeats. So our decimal is going to be 2/10. And the bar notation, I'll do that in a different color, is going to go just over the number that repeats. So our 2 is the number that repeats, so we're going to put a bar notation over the 2. The one thing that you do not want to forget in this problem is our negative sign out in front of our decimal. Okay, if your fraction is a negative, then your decimal is also going to be a negative. This is the same number. -2/9 is the same number or equal to 0 and 2 repeating. Okay, these mean the same thing. It's like I'm Miss West, but I'm also Lauren. So I have 2 different names, but I'm the same person. That's just the same thing we have going on here. This is a decimal and this is a fraction, but they're exactly the same number. Okay? So make sure you have all of that written down before you move on to the next one with us. Then we've got 3/11. Again, we need to put our top number in the house and divide by our bottom number. 11 cannot go into 3, so we're going to put a 0, put a decimal, and then annex a 0. 11 goes into 30 2 times. 2 times 11 gives me 22. Subtract. 2 cannot be taken from 0, so we need to borrow. That becomes a 2. 10 minus 2 gives me 8, and 2 minus 2 is 0. Annex a 0 and bring it down. 11 goes into 80 7 times. 7 times 11 gives me 77. Subtract 7 from 0 we cannot do, so we need to borrow. 10 minus 7 gives me 3. 7 minus 7 is 0. Annex a 0 and bring it down. 11 goes into 30 2 times. 2 times 11 gives me 22. Subtract. We cannot take 2 from 0, so we need to borrow. 10 minus 2 gives me 8. 2 minus 2 is 0. Annex the 0 and bring it down. 11 goes into 80 7 times, and 7 times 11 is 77. When we subtract, we get 3. Now we can see that we're going to start repeating here. We are repeating both the 2 and the 7. So our decimal is going to be 27 hundredths, and it is a repeating decimal. So the bar notation is going to go over both of these numbers because both of those numbers are the numbers that repeat. Okay, so this 0.27 with the bar notation over the 27 tells us that the 27 is the number that continues to repeat on and on forever. Okay, that's all I have for you guys today. I hope you guys have a fantastic day, and I'll see you tomorrow.